Hello everyone, today we're going to be building a bouncing ball effect with Pygame that includes a cool neon trail behind the ball. So the first thing we're going to do is start by importing some libraries. So we're going to import Pygame, import random, and import math. The next thing we're going to do is pygame.init, so initialize Pygame with height equals 1,600. FPS is 60. Now we define screen. So screen is a pygame.display.set mode, and then width, height as a tuple, and then pygame dot, that's it. Wait, no. And then for the trail, we need to create a new screen, which is called trail surface. So global trail surf equals pygame dot surface. Surface. Hold on. Change this to display surface, and then this is width, height, and pygame.scr alpha, which means we can change the transparency. We may create a variable called running and set it to true. Then we say clock equals pygame.time.clock. Then screen color equals 000, which is black. And then now we're going to make a ball class. So we're going to go class ball colon def init self color x y radius speed, and then self dot color equals color, self dot x equals self dot x equals x, self dot y equals y, self dot radius equals radius, and self dot speed equals speed. And now we're going to define some other variables. Self dot angle equals random dot uniform 0, then 2 times math dot pi, and then self dot vx, which is the x velocity, equals self dot speed multiplied by math dot cos self dot angle, and then self dot vy, which is the y velocity, is the same formula except we're using sin instead of cos. Okay, and then we're going to go these two variables are for the trail. Self.history is just an empty list, and self.max trail length, len, is 12. You can change this to make the trail longer or shorter. Then we're going to make a function called move. So we're going to go def move, and we're going to use self as argument. Self.history.append. We're going to append our coordinates as integers, self.x, self.y. Now we're going to do if when self.history is greater than the max trail length, we're gonna remove the first thing in history, so call 0, which is the first index. Then we're going to do self.x plus equals x v self.y plus equals self.vy. And then we're going to do the collision edge check. We're going to say if self.x minus self.radius greater than or equal to 0, self.x equals self.radius, self.vx times equals -1. Else if self.x plus self.radius greater than or equal to width, self.vx times equals -1, and self.x equals width minus self.radius. And then our two lines to box it in the y coordinates are else if if self.y minus self.radius greater than or equal to height, self.y equals height minus self.radius, and then self.vy times equals -1. Else if self.y minus equals self.y minus self.radius greater than or equal to 0, self.y equals self.radius, self.vy times equals -1. Okay, and then that's all for our move function. Now we're going to go into our draw function. Def draw, we're going to say self and then screen equals screen. Then for I, pause, in, enumerate, self, dot history, dot history, factor equals I divided by len, self dot history, alpha equals in, factor times 180, trail color equals self dot color 0, self dot color 1, self dot color 2, and then alpha. Then trail radius equals int self.radius times 0.4 plus 0.6 times factor. And then we're going to go pygame.draw.circle. So this draws a circle. And then it says we're going to use our global trail surface, the trail color, our current position, and the trail radius. Then after the for loop, we're going to draw ourselves, which is pygame.draw.circle, which, wow, draws a circle, and then screen self.color, our position, and then our radius. And then after That is the end of the ball function. And now we're going to do this. Balls equals empty list. And then for I in range, the amount of balls you want. So I'm going to say 1 for now. We're going to say basic equals ball. So we're making this a ball object. So this is basically using the ball class. And we're going to say 25500. So that's the color red. Then for our x, we're going to say random.randint 30 width minus 30. And then for our other one, we're going to go random.randint 30 height minus 30. And then for our last two, we're going to give 10 for the radius and 6 for the speed. And then we're going to say balls.append basic, which adds our ball to the balls list. And now we're in our main loop, we're going to say while running clock.tick FPS for event in pygame.event.get if event.type equals pygame quit running equals false. Then we're gonna go. Our next lines are screen. Why is my cap lock on? Screen.fill screen color screen.lit global trail surf 0,0 and then global trail surf dot fill 0,0,0 and then for ball in balls. So we're looping through our balls, and then we're going to say ball dot draw, which draws the ball, and then ball dot move, which moves the ball. And then we're going to go pygame.display.flip. And we're about to test it. And before we test it, I really need to get 50 subscribers. So if you enjoyed this video or you learned something from it, please subscribe, or just do it for Bob, but subscribe. Yeah, just do it. Okay, so I'm running the program. Oh, nice, we got an error. Okay, so we spelled source alpha wrong, so it's SRC alpha anyway. Now if you run it, it should work, right? Okay, we're going to start with one ball just to see if it works. Okay, we got one ball. Gonna try 10 balls. Okay, so it smoothly handles 10 balls with trails with no lag. We're gonna do 100 balls. Okay, it does it still perfectly fine. What about 200 balls? No noticeable speed difference. 500 balls? It's a bit slower now, but it's still handling it quite well. What about 1,000 balls? Oh my god, look at all of those balls. And finally, just for fun, we're gonna try 10,000 balls. You can't even tell if there are balls, it's just covered with red. Thank you for watching, and don't forget to subscribe. Bye!